Hi, my name is Matthew and welcome to the second cybersecurity topic. Today we'll be talking about public key cryptography. So first off, what is cryptography? Cryptography is the study of scrambling messages so that only certain people can read them. It is broken down into two main processes, encryption and decryption. Encryption aims to scramble a message to hide its true meaning. It takes in a message, as well as a key, and converts it to nonsensical text. To read our message, this recipient needs to have a corresponding key, and this will convert the encrypted text back to its original form. There are two different types of encryption, symmetric encryption and asymmetric encryption. Symmetric encryption uses the same key for encryption and decryption, whereas asymmetric encryption uses two different keys, a public key and a private key. Asymmetric encryption was introduced to deal with a significant problem in symmetric encryption. Let's take a look at the following example. Suppose there are two people, Alice and Bob. Let's say that Alice is a teacher who wants to send solutions of an upcoming math exam to Bob. In symmetric encryption, Alice will encrypt a document with a password, also known as a key. This will result in an encrypted document. She will then send the encrypted document to Bob. Now for Bob to read the document, he needs to know what the password is. This leads to the following problem. How do we send the password? When we send a password, we need it to be secure. This is because if anyone manages to steal the password, they will be able to read the solutions of the test. This is where asymmetric keys, also known as public key cryptography, comes to the rescue. Now in asymmetric encryption, the key used to decrypt the message is different from the key used to encrypt it. There are two different types of keys, a public key and a private key. As the name suggests, the public key is accessible to anyone, whereas the private key is kept hidden. If someone wants to send me a message, they'll encrypt it using my public key. This message can only be decrypted using my private key. Since I'm the only one with my private key, only I will be able to read this message. Now let's go back to Alice and Bob. Suppose Alice wants to send a sensitive document back to Bob. What Bob will do is produce a public and private key pair. If Alice wants to send a message to Bob, Bob will send Alice his public key, while keeping his private key secret. Alice will then use Bob's public key to encrypt her message. She can then send the encrypted document to Bob. For Bob to read this document, he will use his private key in order to decrypt it. Now no one else but Bob can read this document since Bob has kept his private key secret. In this way, public key cryptography is able to resolve the issue existing in symmetric cryptography. Bob and Alice no longer have to have a secure method to exchange the keys. However, this relies on the fact that Bob keeps his private key safe. Thank you for listening.